Alright, so today we're going to do pages 9 and 10 in your handout. 9 and 10 are all about interior and exterior angles of polygons. Now we know that a triangle's angles, interior, add up to 180 degrees. We also know that a quadrilateral's angles add up to 360 degrees. Now let's look at that quadrilateral. Notice that if we take the quadrilateral, we cut it into two parts, we get two triangles. And this triangle's angles add up to 180 degrees, and this triangle's angles add up to 180 degrees, and all those angles put together make the angles in the quadrilateral, which add up to a total of 180 plus 180, or 360. So this is a quadrilateral. So now let's look at a pentagon. Pentagon has 5 sides, and we can cut the pentagon into 3 triangles. 180, 180, 180, for a total of 540 degrees. So let's take a look here. If we have sides and sum of angles, 3 sides gives us 180 degrees. 4 sides gives us 180 times 2, and 5 sides gives us 180 times 3. And overall, n sides would give us 180 times n minus 2, because you can draw 2 fewer triangles inside than the number of sides. So let's go ahead and apply this formula to problems 21 and 22 on page 10. Alright, so here's page 10, number 21. This is a 1, 2, 3, 4, 5, 6, 7 heptagon, and we can divide it up into 1, 2, 3, 4, 5 triangles. So we have 180 degrees times 7 minus 2, which is equal to, let's see, 900 degrees overall. So all the angles inside add up to 900 degrees. Alright, now here is number 22. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. It's a decagon. It can be divided into 1, 2, 3, 4, 5, 6, 7, 8 triangles. So we have 180 degrees times 10 sides minus 2, 180 times 8, which is, I think, 1440. So all the angles inside the decagon, all put together, add up to 1,440 degrees. Alright, now if a polygon is equiangular and equilateral, meaning that the angles are equal and the sides are equal, it's called regular. And if you know that all the angles are the same and you know what all the angles add up to, then you just divide the total angle sum that we already calculated by the number of angles, which we're going to do for problems 1 and 2 on page 9. Alright, Here's number 1. It's a pentagon. A pentagon can be divided up into 3 triangles. So it's 180 times 3, or 540. And 540 divided by 5 angles is, let's take a look here, 5 goes into 40, 8. 108 degrees per angle. Now we have an octagon. And an octagon can be divided into 1, 2, 3, 4, 5, 6 triangles. So 180 times 6. Let's see, that's 600 plus, let's see, 480 for a total of 1080. And let's see. So let's see, 1080 divided by 8 is, let's see, 1, carry the 2, 28, 24, 3, carry the 4, gives us 5. 135 degrees for each angle. Next we have exterior angles. An exterior angle is what you get when you extend a side on the polygon and look at the angle you get outside. So the interior angle and its exterior angle are supplementary. Ugh, my handwriting's terrible. Meaning they add up to 180 degrees. So if we know what the interior angle is, which we can calculate if the polygon is regular from the angle sum that we calculated earlier, then we just have to subtract from 180 to get the size of each supplementary exterior angle. And we're going to do that to numbers 11 and 12 in your handout. Alright, we're back to our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-sided shape, our decagon. So its interior angle sum is 180 times 8. See, 8 times 100 is 800. 8 times 80 is 640 for a total of 1440 degrees, which we divide by 10. That gives us 144 degrees per angle. So the exterior angle, which we'd get if we extended the side here, is 180 minus 144, which is 36 degrees. Now we have the 1, 2, 3, 4, 5, 6, 7-sided polygon. Its interior angles add up to 180 times 7 minus 2, or 5. See, that's 5 times 100 is 500. 5 times 80 is 400. That's a total of 900 degrees. Divided by 7 angles is 1. Carry the 2. 2. Carry the 6. Let's see. 56 would be 8. Carry the 4. 0.5. Carry the 5 would be 7, so we'd round that up to 6. So that's 128.6. 128.6 for each interior angle. And so the exterior angle is 180 minus 128.6. That gives us 0.4. See, if that were, let's see, 130, we would have 50, so it's 51.4 degrees total on the outside. Alright, so now you've got everything you need to know to finish up pages 9 and 10. Over the weekend for homework, I want you to finish up pages 3 and 4 and 7 and 8. 3 and 4 are area problems, and 7, 8 are names of polygons. For 7 and 8, you just look that stuff up on the internet. I'm sure you can find them anywhere. And for 3 and 4, the formulas are easily found online. Just look them up. It's no problem. All right. And I'll see you on Monday.